Welcome to lesson 8.1, adding and subtracting polynomials. So before we get going into the actual work, I want to take a minute and explain what polynomials are, what the different types are, and what's included in those groups. So on the left-hand side over here, we have 4 different expressions. And you can see that A, B, C, and D. We're going to go through and we're going to identify, are they polynomials, and if so, what type they are. So before we get into that work, let's go over our terms. So a monomial, you'll see that word in here. Anything with mono is equal to 1, like a monocle, which is a pair of glasses or a glass that just goes in one eye. You've probably seen it attached to a string before in some old movies. That's a monocle. And then with the word mono means 1. And in this word binomial, we have the word bi, which is equal to 2, like a bicycle. And the word over here, we have the word tri, which is always equal to 3 as a prefix, like a trilogy or a triathlon, equal to 3. Okay, so that can identify the different groupings. And then to be a polynomial, you must have, or the different terms must have, or they can't have, I should say, is they must have positive exponents. Positive exponents, no negative exponents. And they can't have no exponents in the denominator. Just going to make it to the edge. Okay. And you guys know a denominator in a fraction is the bottom number or how many pieces in the whole, right? So with that knowledge, let's go ahead and identify A, B, C, and D. So over here, A, we have 6x minus 4. Well, 6x would have a 1. Technically, we don't need to identify that. But there are 1 and 2 terms. They're only positive exponents, and there are no negatives, so it is a polynomial. That is a yes, it is. And with 2 terms, 1 term and 2 terms, we know that 2 is a binomial. Binomial. Okay, that identifies it. The next one down, we have x to the power of 2. That'll be 1x to the power of 2, same thing. Plus 2xy to the power of 1, and minus 7. So we have 1, 2, 3 terms. They're positive exponents, and there are no exponents in the denominator, so the answer is yes, it is a polynomial. And there are 3 terms, which makes it a trinomial. The next one, I don't have to do too much work before I go back to my rule over here. Notice this rule over here says that there's no exponents in the denominator. Well, we have 5d to the power of 4. Therefore, no, right away, it is not a polynomial. And the last lone survivor over here, D, is 26b to the power of 2. Of course, we know that has 1 term, and it has no negative exponents and no exponents in the denominator. So yes, in fact, it is a polynomial, and because it only has 1 term, it is in fact a monomial. Okay, on to the next. Okay, next we're going to be looking at standard form and leading coefficient of our polynomials here. So in example A here, we have 9x to the power of 2 plus 3x to the power of 6 minus 4x. We're going to put it in standard form and then identify the leading coefficient. Well, to put it in standard form, what we need to do is arrange by powers from greatest to least. So we're going to identify the different powers in this. This is 9x to the power of 2. This is 3x to the power of 6. This is negative 4x to the power, well, it would be the power of 1, right? But we don't need to write that in. So I'm just going to arrange them by dominance. And don't forget, this 9x would actually be a plus 9x. It's unwritten, but we know that's a plus 9x. So I'm going to go ahead and I can easily see that the 3x to the power of 6. 6 is the highest power in there. So in standard form, I would rewrite it as 3x to the power of 6. And then I'm going to go ahead and add my plus 9x to the power of 2. And then I'm going to go ahead and add my minus 4x. And I don't need to put the power of 1 there, but yeah, that's how it goes. And when we get over here to our leading coefficient, this word leading coefficient is the number that kicks off, that really kind of kicks off our expressions here. And in this case, we've identified our leading power, our highest power in standard form is this 3x to the power of 6. And leading coefficient is just the first term, so that's the 3 in there. That's our leading coefficient, okay? And a more complex one down here at the bottom in B, we have 12 plus 5y plus 6xy plus 8xy to the power of 2. Well, here's where it gets a little interesting. To identify these, this 12 doesn't have any power beside it, so that's going to come with no rank last. This 5y is actually the power of 1, but that's again unwritten. I'm going to change the yellow just to make it more obvious here. Now that's a 1, but it's unwritten. And same here, 6x is to the power of 1, and the y is to the power of 1, which actually gives us a exponent value of 2, right? Those are two exponents. And here we have 8x, which is also a 1, unwritten, and y2. This gives us a 3 exponent value. Do you see how that works? I'm arranging them from least to greatest. This would have a combination of 3. This would have a combination of 2. This one has a value of 1. This has a value of 0. So now I'll go ahead and rank those. It would become 8xy to the power of 2 plus 6xy plus 5y plus 12. And then our last step is identifying this leading coefficient. And in this case, our first term, our highest powered over here is 8xy to the power of 2, and our leading coefficient is that first term of 8. Okay, now that we have a better understanding of what polynomials are and also how to write it in standard form and our leading coefficient, let's get into the actual work of adding polynomials. You'll see here I have an expression that I need to evaluate, but before I do that, I'm going to try and simplify by joining or grouping like terms. So I'm going to rewrite the question again without the parentheses. It's not needed in this case. Plus 2y minus 3 plus 2 minus 4y plus 5y to the power of 2. I'm going to switch colors to try and give you a clear indication of what I'm doing here. So looking for like terms, I can see my 7y to the power of 2 over here and my 5y to the power of 2 over here. And what I'm going to do on this one is I'm simply going to do 7y plus 5y. 7y, to the power of 2 plus 5y to the power of 2. And that I'm going to rewrite it over to the side over here so it's a little clearer. It's going to be 12y to the power of 2. Okay? And then switch colors again to make it, again, a little easier for you to see what I'm doing. I'm going to look at my 2y next. I have 2y over here, and I have negative 4y over here. So for these two, what I'm going to do is my negative 4 plus 2. And negative 4 plus 2 is equal to, I better switch colors back. I'm going to keep the same color and just as I go. It's negative 2y, right? If I do that, negative 4 plus 2. And for my last identifying like terms over here, let's use a purple. I'm going to go ahead and see my whole numbers. Oops, geez, I accidentally erased it. My 3 and my 2. And so what I'm going to do over here is I'm going to join those two with a line and just put negative 3 plus 2. And if you do negative 3 plus 2, you're going to end up with a negative 1. I'm going to rewrite this for you in a single color so it makes it easier to see. And I have my final, reworked expression is 12y to the power of 2 minus 2y minus 1. And of course I did that by adding and joining like terms. Okay, and our last example is going to be subtracting polynomials. Again, before we do this, we need to group our like terms. So I'm going to go ahead and rewrite it once more underneath. I'll use yellow as my beginning, and then I'll go from there. So I'm going to rewrite it as 6y to the power of 2 plus 8y to the power of 4 minus 5y. And here's where it gets interesting. I need to make sure I distribute this negative across all of these terms over here, which means they kind of reverse, so that negative 9 actually becomes a it becomes keep it minus 9y to the power of 4. But a negative multiplied by a negative, this negative multiplied by the negative, it's actually going to give me a positive. So that's going to be positive 7y. And of course, a negative and a positive is also equal to a negative, negative 2y to the power of 2. So the biggest trick when you're dealing with subtracting polynomials is remembering to distribute the negative, if it is, well, it should be a negative because you're subtracting across the terms in the parentheses. Okay, so now that we have that kind of sorted out and rewritten, identifying the negative property in there, I'm going to go ahead and group my like terms. In this case, again, like we talked about before in standard form, I group the highest by powers. So you'll see that the 4 over here, this indicates that, of course, this is the highest. So what I'm left with is this 8y to the power of 4 and my 9y to the power of 4. But of course, that is, I'm going to draw a little line and show you what I'm doing here. That's 8y to the power of 4 subtracted by 9y to the power of 4, which if you're playing along at home will actually give you a negative y to the power of 4. Okay? And we can move along to our second set of like terms, and that's going to be our 2 to the power of 2, or squared over here. I'll draw another line carefully and show you what I'm doing over here. So that's going to be, my second one is 6y to the power of 2 minus 2y to the power of 2, and that should give you a positive 4y to the power of 2. And then the last, let me change color one more time for you, and we have our whole numbers, our negative 5y and our positive 7y over here. So we're going to go ahead and make those our next, and what I'm going to do for this one is negative 5y plus 7y. And if I have negative 5 and I add 7, that should give me a positive 2, so positive 2y. And finally, just to make it super clear, I'm going to go ahead and rewrite this in a color I haven't used yet. Let's do this orangey color, and my final breakdown is going to be negative y to the power of 4 plus 4y to the power of 2 plus 2y. Okay? And that's adding and subtracting polynomials.